Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up the 7th numerical on sampling theorem. I will read out the question first. The signals G1 of t equals 10 cos 100 pi t and G2 of t equals 10 cos 50 pi t are both sampled with a sampling frequency of Fs equals 75 Hz. Show that the two sequences so obtained are identical. Note that we have two signals G1 of t and G2 of t which are sampled at Fs equals to 75 Hz. The question is to show that the sampled signal sequences are exactly the same. Let us start with the solution here. I'll start with the first signal which is G1 of t which is equals to 10 cos 100 pi t. So, this is equivalent to 10 cos 2 pi f1 t. Therefore, f1 is equals to 50 Hz. Let me call this as equation 1 now. Now, since we are asked to find the spectra, we are supposed to take the Fourier transform of equation 1 on both sides. So, I will write taking Fourier transform on both sides of equation 1. Now, you should note that Fourier transform of cos 2 pi f1 t is equal to 1 by 2 into delta of f minus f1 plus delta of f plus f1. This is a standard formula. Therefore, when I take the Fourier transform on equation 1, this would become G1 of f is equal to, we have 10 multiplied by 1 by 2 into delta of f minus f1 which is 50 Hz plus delta of f plus f1 which is again 50 Hz. Let me call this as equation 2. Now, we are very clearly told that this signal is sampled. So, the spectra of the sampled signal is given by, we have G1 delta of f equals to Fs into summation m varying from minus infinity to plus infinity g of f minus m Fs. This is a standard equation as I said. To be very precise, the RHS has to be G1 of f minus mfs. So, I will add the subscript 1 here. Now, to obtain G1 delta of f which is LHS of this equation, I have to now go back to equation 2 which is G1 of f and substitute wherever there is a f by f minus m into fs term, which I will do now. So, G1 delta of f is equals to fs which is actually 75 multiplied by summation m varying from minus infinity to plus infinity. Now, I have to take the RHS of equation 2 which is 10 multiplied by 1 by 2 which is 5 into delta of, I said wherever there is a f I have to substitute it by f minus mfs. So, it will be f minus fs is given as 75. So, it will be 75 m. Then we have the minus 50 here. Similarly, we have delta of f minus 75 m plus 50. Let me just try to simplify this. I'll call this as equation 3. This will be an important equation. Now, let me go to the second signal that is given. So, the second signal is G2 of t equals 10 cos 50 pi t. So, if I write it as 10 cos of 2 pi f2t, I will obtain f2 to be 25 Hz. Let me call this as equation 4. Now, I am going to apply Fourier transform on both sides of equation 4. So we will have G2 of f is equal to 1 by 2 multiplied by 10 into delta of f minus f2, which is 25, plus delta of f plus 25. Let me simplify this. So this will be equals to 5 into delta of f minus 25 plus delta of f plus 25. I'll call this as equation 5, and please note this is G2 of f. Right. Now, once again, to obtain the spectra of G2 of f, I will be applying the equation for the sampling, which is G2 delta of f is equal to Fs multiplied by summation m varying from minus infinity to plus infinity G2 of f minus m Fs. So this is equal to Fs is equal to 75 multiplied by summation m varying from minus infinity to plus infinity. I go back to equation 5, and wherever there is an f in equation 5 RHS, I'll substitute it by f minus mfs. So therefore it will be 5 into delta of f minus 75m minus 25 plus delta of f minus 75m plus 25. Okay, so let me just try to simplify this. So this will become right. I'll call this as equation 6. Now, if you look at the question, we are asked to prove that the spectra obtained when these two signals are sampled at a sampling frequency of 75 Hz are exactly the same. However, at this stage, if you look at equation 6 here and the equation 3 here, you will find they are not exactly the same. So, some mathematical alteration is required to make them equal to one another. So, what I am going to now do is, I am going to let m is equals to some variable L minus 1 in the first term of the equation 6, and m is equals to another variable k plus 1 in the second term of equation 6. Please note this I am doing only to make sure the equations match each other after sampling. So let me now substitute these values into equation 6 and try to simplify. So G2 delta of f is equal to, since we have to now change the variable, I'll split the summation as well. So I'll take up the first term now, which is 375 into summation. There is a change in variable. Now the variable is L here. The previous limits of summation are minus infinity to plus infinity, so they will also remain the same. Then we have delta of f minus 75 into L minus 1 minus 25. This is our first term. Then we have plus, the second term is 375 into summation, variable now is k varying from minus infinity to plus infinity. We have delta of f minus 75 into k plus 1 plus 25. Right. So now you try to simplify this. So this is equals to 375 into summation L varying from minus infinity to plus infinity, delta of f plus 50 minus 75 L plus, in the second term we have 375 into summation k varying from minus infinity to plus infinity, delta of f minus 50 minus 75k. Let me call this as equation 7. Now, you must note that the variables L and K are absolutely dummy variables. So, it is completely possible to replace these variables by m. So, what I am going to now do is let the values of L and K be replaced by the variable m. So, when I do this into equation 7, let us see what happens to equation 7. So, let me just rewrite equation 7 here. G2 delta of f is equal to 375 summation Now, since the variables L and K are replaced by M, one summation is enough and it will vary from minus infinity to plus infinity. Then we have delta of F plus 50 minus 75M, then plus delta of F minus 50 minus 75M. Let me call this as equation 8. Okay. Now, let us go back to equation 3, which was the outcome of the first sampled signal. Look at the RHS of this equation and then you come back to the equation 8 we just obtained and compare the RHS of equation 3 with equation 8, and we will find that equation 3 and equation 8 are one and the same. Therefore, we can now conclude that the sampled versions of G1 of t and G2 of t are identical. Right, that's it about this numerical. If you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.